You're welcome to class.
This is my second lesson on number basis, and in this lesson we'll be looking at conversion of numbers in other bases to base 10. If you have not watched the first lesson, please do that, because that will give you the foundation you need to understand the lesson I am teaching today. Let's look at this example. Previous lesson, I was able to introduce you to place value in different number bases. This place value in different number bases is actually the foundation of conversion from one base to another. So let us go on to do the 8. The place value of this 7 is 8 raised by 0. The place value of this 2 is 8 raised by 1. So we'll be using this place value to expand each of the digits to get their conversion and their equivalence in base 10. Let's go. This is equals to 2 8 raised by 1 plus 7 8 raised by 0, which is equals to 2 times 8 equals to 2 times 8 plus 7 times any number raised by 0 is equals to 1. So that is 7 times 1, equivalence of which is 16 plus 7. 16 plus 7 is 23. This means that 2 7 base 8 is equals to 23 in base 10. This is not called 27, because 27 means 2 tens and 7 units. This is not 2 tens. This is 2 eights and 7 units, 7 ones. Another example is a number in base 2, 11011 in base 2, to be converted to base 10. We start with the place value of each of the digits in the number. Because this is a number in base 2, the place value are going to be having powers of 2. The place values are going to be powers of 2. Starting from the unit, this is 2 raised by 0, which is equals to 1, which is unit. This is 2 raised by 1, this is 2 raised by 2, this is 2 raised by 3, and this is 2 raised by 4. We will be expanding using each of the place value. So I have 1 times 2 raised by 4 plus 1 times 2 raised by 3 plus 0 times 2 raised by 2 plus 1 times 2 raised by 1 plus 1 times 2 raised by 0. This translates to 1 times 2 raised by 4 is 16. 2 times 2 times 2 times 2, which is 16. The value of this 1 is 1/16. And that is why you cannot call this number 11,000, because this one is not 10,000. This one is not 1,000. This is 1/16, 1/8, 0 fours, 1 twos, and 1 unit, or 1 ones. So we have 1 times 2 raised by 4, which is 1 times 16, plus 1 times 8, that is 2 raised by 3, plus 0 times 4, plus 1 times 2, plus 1 times 1. Any number raised by 0 is equals to 1. That is 1 times 1. This translates to 1 times 16 is 16, plus 1 times 8, 8. 0 times 4 is 0. 1 times 2 is 2. 1 times 1 is 1. By the time we add that up, we have 16 plus 8, 24. 24 plus 2, 26. 26 plus 1, 27. 27. 2 tens, 7 units, 27. That means 11011 in base 2 in binary is equivalent to 27 in base 10. Let us look at the conversion of 1534 in base 6 to base 10. 1534 base 6. The place value of this 4 is 6 raised power 0. The place value of this 3 is 6 raised power 1. The place value of this 5 is 6 raised power 2. The place value of this 1 is 6 raised power 3. So I have 1 times 6 raised power 3 plus 5 times 6 raised power 2 plus 3 times 6 raised power 1 plus 4 times 6 raised power 0. This is 1 times 6 raised power 3 means 6 times 6 times 6, which is 216, plus 5 times 36 plus 3 times 6 plus 4 times 6 raised power 0, which is 1. The multiplication of each of these will give us 216 plus 5 times 36, which is 180. 3 times 6, 18, plus 4 times 1, which is 4. By the time we add these numbers together, we are going to be having 418, 418 in base 10. That means 1534 in base 6 is equals to 418 in base 10. Now let us take an example in bases higher than base 10. 8a 9f in base 16 is to be converted to a number in base 10. Like I said earlier on, if you have not watched my first lesson, which is Introduction to Number Bases, please go and do that. Because in that lesson, I explained that in every basis, in all bases, you will never find a digit, a single digit, that is up to the base or more than the base. This is base 16. All the digits you can find in base 16 are 0 to 15. But there are numbers like 10 are 2 digits. 11, 12, 13, 14, 15 are 2 digits. And it will be confusing to write them as 2 digits in this base. It will be confusing. You'll be looking at 10 as 1, 0. And that is why alphabets are employed to represent those numbers. So 10 is represented with A, 11 is represented with B, 12 with C, 13 with D, 14 with E, and 15 with F. You will see how I make use of this in conversion now. 8A, 9F in base 16. The place value of this F is unit, which is 16 raised power 0. The place value of 9 is 16 raised power 1. The place value of A is 16 raised power 2. while the place value of 8 is 16 raised power 3. The value of 8 here is 8 4096 because 16 raised power 3 is 4096. So this is 8 4096. This is A, which is 10. 10 256 because 16 raised power 2 is 256. This is 9 16ths, and this is F, which is 15. 15 units because 16 raised power 0 is equals to 1. This is 8 times 16 raised power 3 plus A times 16 raised power 2 plus 9 times 16 raised power 1 plus F times 16 raised power 0. Here we have 8 times 4096 plus the A is 10. That is 10 times 256. 16 raised power 2 is 256 plus 15 times 16 raised power 0 is equals to 1. That is 15 times 1. 2768 plus 10 times 256 gives us 2560 plus 9 times 16 is 144 plus 15 times 1 is 15. We have 35,487. 35,487. 35,487. 889F in base 16 is equals to 35,487 in base 10. The conversion of this decimal to base 10. We are still going to be employing the method of number of place value. Solution. 1.001. I will start with the units. The place value of this one is 2 raised power 0, which is equals to 1. That is the unit. The place value of this 0 is 2 raised power minus 1. This is 2 raised power minus 2. And this one is 2 raised power minus 3. Those are the place values. So we'll be using the place value to convert from base 2 to base 10. So here I have 1 times 2 raised power 0 plus 0 times 2 raised power minus 1 plus 0 times 2 raised power minus 2 plus 1 times 2 raised power minus 3. This is equals to 2 raised power 0 is equals to 1. That is 1 times 1 plus 0 times half plus 0 times quarters plus 1 times 1/8. That is, we have 1 times 1, which is 1, plus 0 times half is 0. 0 times quarters is 0. 1 times 1/8, that is 1 times 1/8. That is 1/8. So, this number gives one whole number 1/8. 1/8 is equals to 0.125. 0.125. So this is 1 plus 0.125, giving us 1.125 in base 10. So 1.001 in base 2 is equivalent to 1.125 in base 10.
Thank you for watching. Please subscribe to our channel for more interesting lessons.